Hey everyone, this video is just a quick check-in to make sure that you understand how to use trig functions to solve right triangles in the unit circle. Up at the top here you have your three special triangles, the 45, 45, 90, the 30, 60, 90, and the reverse of that, the 60, 30, 90. What this is doing is just showing you the ratios that we know exist between the three sides of a triangle in these situations. So we know in an isosceles right triangle that the two legs are congruent, they're the same length, and we usually set that to be 1 unit long, which means that the hypotenuse is square root of 2 long. In a 30-60, the shortest side is 1 unit long, the longer leg is square root of 3, and the hypotenuse is 2. And it's the same here, we just reversed the legs. So these triangles are not set in the unit circle, because the unit circle has to have a hypotenuse of 1 unit long. So you can see that these hypotenuses are square root of 2 and 2, so they're not in the unit circle. Okay, but we can use the same ratio. It doesn't matter the size of the triangle. If it's a 30, 60, or a 45, the ratios, the comparisons of the two sides are going to be the same. Okay, so when we talk about the unit circle or any point in the unit circle, we have three sides of a triangle. We will always consider the x coordinate to be the adjacent side. Remember, our reference angle that we talked about, theta, is always on the x-axis. So this x coordinate will always be your adjacent side. The y coordinate will always be the opposite side. And the radius, r, will always be the hypotenuse. So we're trying to get away from using these terms opposite, adjacent, and hypotenuse and just talking about the coordinates themselves. So over here for your basic trig functions for sine, we're going to put in that your sine coordinate is the opposite side, which is the y coordinate, divided by the hypotenuse, which is your radius. Your cosine ratio is going to be the adjacent side, which is x, over your hypotenuse r. And your tangent side is going to be the opposite side, which is the y coordinate, divided by the x coordinate. Okay? So on our unit circle, we can then realize that, well, because I have a fixed hypotenuse, because it's a unit circle, I know that the radius is always going to be 1. And so once we realize that the radius and the hypotenuse are always 1, that simplifies all of these ratios. So that means that the cosine of theta is going to be x divided by 1. Well, dividing by 1 is pointless, it doesn't change it. So that immediately means that the x coordinate is the same as the cosine ratio for theta. And it's the same for the y coordinate. The y coordinate is going to be the same as the sine ratio for theta. So in the unit circle, we no longer have to worry about comparing anything to the radius or the hypotenuse because it's always 1. And so we get a lot of special properties when we look at this. You can realize that, well, if I have an angle, they call it alpha here, that I will always have cosine of that angle as my adjacent side, sine of that angle as my opposite side, and that will always create a hypotenuse of 1. Okay? And so that tells us that if I know these three sides, I can actually create a statement using the Pythagorean Theorem. Because I know that the two shorter legs squared and added up equals the hypotenuse squared, we get this Pythagorean property. That if you take your sine ratio and square it, add it to your cosine ratio squared, that should always equal 1. Okay, it's a really important property. You'll use it a lot in trig, pre-calc, and calculus. Okay. So down below, this is mostly practice for your quiz. You're going to have a lot of questions where you're asked to find the trig ratios for various special angles on your unit circle. So I wanted to show you how to use your unit circle to find these values. Okay, so when you're taking your quiz or you're trying to fill out these, you should have your completed unit circle with you when you do it. It's going to be super helpful. And if you lose it or you want to double check to make sure that yours is correct, you can always just Google unit circle and something similar to this will come up. Some unit circles are more detailed than others, and we'll talk about what to do if it's not fully filled in. So let's start with an early, easy one, sine of 45 degrees. So on my unit circle, I should be able to go to the 45 degree rotation mark right here. This is the terminal side starting from 0. And this point, I'm looking for the sine of 45 degrees. So if I imagine my right triangle coming down right here, the sine coordinate would be this y value, right? From our image above, we saw that this vertical distance was always the sine ratio. So on your unit circle, though, you're given the coordinates, square root of 2 over 2, square root of 2 over 2. So you know the height of this point is square root of 2 over 2. So this is my sine ratio for any 45 degree angle. So over here then, you would just fill in square root of 2 over 2. Okay, and once you start doing this enough, you'll start to memorize these. If you have a negative angle, there's two ways you can go about it. You can either use your knowledge of direction to say, okay, negative 45 degrees is going to go in the clockwise direction. So negative 45 degrees will line me up with this 315, because I'm technically starting at 360 and then subtracting 45 degrees from it to get to 315. Or you can find a coterminal angle by adding 360. So you can add 360 to get a coterminal angle and see that 315 and negative 45 are the same location. Either way, you should end up on this spoke, this line, which is at this point. Okay, that's the same as 7 pi over 4. So because we want the cosine ratio, we're going to look at the x coordinate now, which is positive square root of 2 over 2. Okay, make sure you pay attention to your negative signs, okay, because you can have negative ratios as we go around the unit circle. Let's try one with the radians. We'll do sine of pi. So if I look at pi rotation, that puts me all the way over here on the negative x-axis. And so my coordinates are negative 1 and 0, which is kind of weird for ratios, but they do exist. You just need to remember which one is which. So always remember that the cosine of theta is your x coordinate. The sine of theta is your y. And that exists, that's true for even your quadrantals. So for my sine ratio for pi, which is 180, I'm going to use the y coordinate of 0. Okay, that's my ratio, 0. For cosine of pi over 2, that's down here. I'm going to use the x coordinate because I'm using cosine. That one is also 0. Okay, so let's talk about tangent. Tangent is tricky because remember, if you looked above, the tangent one is actually the ratio of y over x. So we actually have to do a little bit of math to calculate tangent. A lot of times students on their unit circles will just fill in all of the tangents ahead of time so they have them ready to go. But if you don't have tangent on your unit circle, you can always figure it out by doing y divided by x. Think of like slope, like rise over run. It's the same idea. Your y coordinate divided by your x coordinate. So for tangent of 60 degrees, I'm going to go to the 60 degree mark. I can see that I have my sine and I have my cosine, but to get tangent, I need to divide them. So I'm going to do the square root of 3 over 2 divided by 1/2. Okay, when you're dividing fractions, you're really multiplying by the reciprocal. So instead of dividing, I'm going to multiply by 2 over 1 and then reduce. So the 2's reduce and you get the square root of 3 over 1, which reduces to the square root of 3. So the tangent of 60 degrees is the ratio of square root of 3 to 1. Okay. So if you wanted to, on your nice complete unit circle, you could just add like a square root of 3 out to the side here, just to remind you that, oh, the tangent of this one will always be square root of 3 at 60 degrees. Let's look at the tangent of 0. If you're at your quadrantals for tangent, you still use the 0 and the 1 to set up your ratio. So I'm going to do y 0 over 1. So my tangent of 0 is 0. Okay. There is a tricky one with that. Let's go ahead and look at the tangent of pi over 2. Skip down to this one. Because if you're at pi over 2, you'll notice that your y is 1 and your x is 0. So your tangent should be 1 over 0. If you're dividing by 0, that is an undefined value. So there is no tangent ratio at pi over 2. It is undefined. So in here we'll put undefined. You can just abbreviate with the first 5 letters. Okay? And that's pretty much it. That's a good majority of the quiz this week. If you have any questions, feel free to email me. Go ahead and fill out this as practice and upload it for credit for this week's lesson. Hope you guys are staying safe. Talk to you soon.